All right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD 1000 Web Development Technologies class, I've been creating a series of video presentations based on the Mozilla Developer Network Learn Web Development series. I'm coming towards the end of the JavaScript section, and we're talking now about asynchronous JavaScript, and we are in the second lesson here, which is on general asynchronous programming concepts. As the intro here says, we'll run through a number of important concepts related to asynchronous programming and how this looks in web browsers and JavaScript. So, normally a program's code runs straight along with only one thing happening at a time. If a function relies on the result of another function, it has to wait for that other function to finish and return, and until that happens, the entire program is essentially stopped from the perspective of the user. Think about it this way. Let's assume that we've written a payroll program, and we've written it in such a way that we have to input what the person's first name, then we input the person's last name, then we input the number of hours the person worked, then we input the amount they make per hour, then we finish up by figuring out their gross pay, and we do that based on whether or not they worked any overtime. All right. So as we go through all this stuff, basically, if something hangs up the program for whatever reason, the program virtually stops until it has whatever it needs to continue. So it says Mac users, for example, sometimes experience this as the spinning rainbow colored cursor, which is how the operating system says the current program you are using has to stop and wait for something to finish up. And Windows has something similar. All right. They mention here that this is a frustrating experience and isn't a good use of computer processing power. Well, it's not a good use of human power either if the user has to wait for something to happen. There's no sense sitting there waiting for something when you could let the other task chug along on another processor core and let you know when it's done. This lets you get other work done in the meantime. As it says, this is the basis of asynchronous programming. So, as mentioned right here, with asynchronous programming, it's up to the programming environment you are using. And since we're working with web development, it'll be up to the browser to provide you with APIs that allow you to run tasks asynchronously. What we don't want to have happen is what's referred to as blocking code. So as mentioned right here, asynchronous techniques are useful, particularly in web programming. When a web app runs in the browser and executes, and it does something that's going to take some time, the browser, for lack of better words, can appear to be frozen. This is known as a blocking condition, or just as blocking, where the browser is blocked from continuing on to perform whatever else it's supposed to perform. So it says, let's take a look at a couple of examples to see what we're talking about. Well, when you look in here, this may not seem like a long time, but if you look here, it's counting from 1 to 1, 2, 3, 4, 5, 6, 7. So it's counting from 1 to 10 million right there. All right. So it says in our simple sync example, we add a click listener to a button so that when it's clicked, it runs a time-consuming operation. As it says, it's calculating 10 million dates and then logging the final one to the console, and then it'll add this paragraph. All right, let's take a look at it. Again, I've taken the idea that I like running these programs. I think it makes more sense so you can actually see them running, verify, if nothing else, indeed, that it's working the way that you think it's going to be working, etc. So I'll keep that in the editor. There it is. So this is right now called bounce, so I'm just going to rename it. So I'm going to do a file, save as. I did some cleanup on my machine before, as you can see. There's not much there right now because it's been put into folders. So I'm going to call this async.html. So let's go back into here and run it and click me. Now it didn't seem like it was a long time. All right, I'm going to refresh it and run it again. But let's kind of count. 1 Mississippi, 2 Mississippi, so about 2 seconds, somewhere in there. And as you guess, if we bump it up to 100 million, it's going to be even longer. All right, and 1 billion, even longer still. So again, if I bump this up, put another 0 in here, and try to run this again, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7. So you can see, all right, not sure exactly what's going on in here right now. Maybe I've exceeded the size, but I didn't. Oh, there it goes. So it finally added it. Now, again, that may not seem like that long a time, 10 seconds, 15 seconds to you or to me. To the computer, in some ways at least, it almost seems like an eternity. All right, because it's just taking, you know, that's time when the system could be doing something else. So it says, when running the example, open your console and click the button. You'll notice that the paragraph does not appear until after the dates have finished being calculated and the console message has been logged. So let's do it the way they've mentioned. So let's come back in here, remove that extra 0. So it's back to 10 million. We'll come back into here and we will inspect. So we'll go into the console. There it is. And I'm going to refresh and I'm going to click me. All right. And again, it's not that it took that long. All right. You can see also it says that this was from line 18, which is the log. All right. Now, sometimes when you go through this stuff, and this is what I have a tendency to do, and that is very quickly here, when people come in and go, okay, give me an example, and give me an example that's not computers so I can try to understand it. Now, when you think about it, this is not the way, what I'm about to tell you, it's not the way it works, but what is supposed to happen is most human conversation is supposed to be synchronous. In other words, I talk, you listen. I get done talking, you begin talking, and I listen. You finish talking, I begin talking, you listen. You can see how that goes. All right? But that's not really how it works, but that's how it's supposed to work. And when you think about something being asynchronous, this is an example that I read online a few years ago, and I thought it was pretty good. They said, imagine that you've got an administrative assistant, and this person's job is to coordinate what goes on for their boss and maybe their entire department. So they're online, and maybe they're scheduling a meeting, and while they schedule the meeting, someone walks in to ask them a question. So they answer the question. All right. And the person leaves, and now the phone rings. Well, when you think about it, what's happening? Well, they're able to basically stop whatever it is they're working on to do something else. Not something else that's deemed more important, but something else that maybe needs their attention currently. Again, not necessarily because it's more important. All right, it says when running the example, again, open your browser, you'll notice the paragraph does not appear. That was true. The code runs in the order it appears in the source, and the later operation doesn't run until the earlier operation finished running. In other words, this thing that was right here that said this is a newly added paragraph, all right, that didn't end up running until this had gone all the way through. We had logged the last date, and then this happened. So it says the previous example here is fairly unrealistic. You would never calculate 10 million dates in a web app, but it's meant to simulate something. All right. In the second example here, simple sync UI blocking says we simulate something a little bit more realistic you might have come across on a web page. We block user activity with the rendering of the UI. In this example, there are two buttons. A fill canvas button, and when you click it, it fills the canvas area with 1 million blue circles, and a click me for alert that when clicked shows an alert message. So let's again grab this. In fact, we'll just grab it from here. I'll again grab all of the code. And even though it's got a different name, that's fine. It'll work fine in here. Let's save this. And let's come in, refresh, and we'll run this. Okay? So you look at this and you go, well, why is it all blue? Well, it made 1 million blue circles, so it filled the entire area. And while it was doing that, when I tried to click the button, nothing happened. So again, refresh, click the fill canvas. Now I'm clicking for the alert, and nothing's happening. Now when it fills, I'll get it right away. You can see I'm getting it basically for every time I click that. All right. So it says if you click the first button, then quickly click the second one, you'll see that the alert does not appear until all the circles have finished rendering. In other words, the first operation, that operation of coming up with those 1 million different circles, blocked the second one, the alert, from operating until the first one had finished running. It says, okay, in our case it is ugly and we are faking the blocking effort, but this is a common problem that developers come up with all of the time. All right, so as mentioned here, why is this? The answer is because JavaScript, by its very nature, is single threading. Now, we'll talk about threads in just a minute, but before we do, I went online and found this. I don't know if it's good or not good, but it's up, I guess it's a matter of opinion. So it says synchronous JavaScript. As the name suggests, synchronous means to be done in sequence. Every statement of the code gets executed one by one. So basically, a statement has to wait for any other earlier statements to get executed. So they give an example here. So this will say hi, then there'll be a line break, then Mayuk, then a line break, and how are you? Hello, line break, Mayuk, line break, how are you? All right. It says in the above code snippet, the first line of the code, the hi, will be logged first, then the second line will be logged after it's completed, and then the third line. So as we can see, the code works in sequence. Every line waits for the previous one to complete. With asynchronous JavaScript code, as it says, it allows the program to be executed immediately, where the synchronous code will block further execution until it finishes the current one. And it says, this may not seem like a big problem, but you get a bigger picture of it when you realize that this can slow things down. All right, so what do we have here? We've got hi, and then a line break. And then notice we're going to wait for 2 seconds. All right. And after the 2 seconds, it should come up and right on the screen. Let us see what happens. Now, if this works the way I think it will, it'll write hi, and then the line break, and then another line break, and then the word end, and then a line break, and then you'll see let's see what happens. So hi, line break, end, line break. Let us see what happens right there. It says, so what the code does is it first logs the high, and then rather than executing the set timeout, it does what it's supposed to do. The set timeout means it's supposed to wait for 2 seconds. So it waits, and then it runs what comes after the set timeout. So at first, as usual, the high statement gets logged. As we use browsers to run JavaScript, there are web APIs that handle these things for users. So what JavaScript does, it passes the set timeout function to one of these APIs, and then we keep running our code as usual. So there's no blocking that happens. As it says, it does not block the rest of the code from executing. And after all of that code has been executed, it gets pushed back to the call stack and then finally executed. So it says this is what happens with asynchronous JavaScript. Okay, I don't know if that helped or not, but I just thought it would kind of help to go over something that was maybe a little more generic in nature. All right, I'm at 16 minutes, so we'll finish this up talking about threads in the next lecture.